Welcome to the lesson on finding square root of non-square numbers without using calculator. Introduction. Any whole number that can be expressed as a square of an integer is referred to as a square number. Examples of square numbers are 1 equal to 1 squared, 4 equal to 2 squared, 9 equals to 3 squared, 16 equals to 4 squared, 25 equals to 5 squared, and so on. It is quite easy to find the square root of a square number without using calculator. For example, square root of 4 is equal to 2, since 2 times 2 is equal to 4. Square root of 9 is equal to 3, since 3 times 3 is equal to 9. Square root of 16 is equal to 4, since 4 times 4 is equal to 16, and so on. A non-square number is the whole number that cannot be expressed as a square of an integer. Examples of non-square numbers are 2, 3, 5, 6, and so on. It is not so easy to find the square root of a non-square number without using calculator. However, some mathematicians have developed techniques on how to estimate the square root of such numbers. The commonly used method for estimating square root of non-square numbers is given by this formula. Square root of z is approximately equal to x plus z minus x squared all over 2x, where x squared is the next square number less than z, and x is the square root of x squared. For example, using the formula square root of z is equal to x plus z minus x squared all over 2x, let us find the square root of 5. The next square number less than 5 is 4, so x squared is 4. Z is 5. Square root of 4, which is x, is 2. So this will then give us square root of 5 is approximately equal to 2 plus 5 minus 4 over 2 times 2. 5 minus 4 is 1 divided by 4, that is 0.25. So therefore square root of 5 is 2 plus 0.25, which is equal to 2.25. Check. Multiplying 2.25 by itself gives 5.0625. This is greater than 5, meaning that this formula overestimates the square root of 5. Also, let us find the square root of 15 using the formula. Here, the next square number less than 15 is 9, that is x squared is 9. The square root of 9 is 3, that is x is equal to 3, and z is 15. That will then give us square root of 15 is approximately equal to 3 plus 15 minus 9 all over 3 times 2. 15 minus 9 is 6, divided by 6 is 1. 3 plus 1 is 4. So therefore square root of 15 is estimated to be equal to 4. Check. Multiplying 4 by itself gives 16, and 16 is greater than 15, meaning that this formula also overestimates the square root of 15. Generally, the above formula provides an upper bound for the square root of z. Alternative method. Suppose we wish to find the square root of a non-square number z. The alternative procedure is as follows. Step 1. Find the next square number x squared less than z, and also the next square number y squared greater than z. Step 2. Find the distance m equals to z minus x squared and the distance n equals to y squared minus z. Let us demonstrate this on a number line. Let this be the point representing a non-square number z. We want to find the square root. And let this be the point x squared, which is the next square number less than z. And the square root of x squared is x. Let this be the point y squared, representing the next square number greater than z. And the square root of y squared is y. Then the distance from x squared to z is m. That's this distance is m, z minus x squared. While this distance is n, y squared minus z. Step 3. Let us now estimate the square root of z using the interpolation formula given below. Square root of z is approximately equal to m times y plus n times x all over m plus n. Or we can use the formula square root of z is approximately equal to x plus m all over m plus n. I call this formula lower interpolation formula because x is the square root of the next square number less than z. Or we can use the formula square root of z approximately equal to y minus n all over m plus n. And I call this one upper interpolation formula because y here is the square root of the next square number greater than z. The above formulas provide a lower bound for the square root of z. Example 1. Find square root of 10. Solution. The next square number less than 10 is 9. And the next square number greater than 10 is 16. And z is our 10. Then the distance m is 10 minus 9, which is equal to 1. And the distance n is 16 minus 10, which is equal to 6. Let us show this on a number line. Here is the point representing 10. And we wish to find the square root of 10. Here is the point representing the next square number less than 10. That is x squared equal to 9. And the square root of 9 is 3. This point represents the next square number greater than 10. That is y squared equal to 16. And the square root of 16 is 4. Now the distance from 9 to 10 is m, and that m is equal to 1, while the distance from 10 to 16 is n, and n is equal to 6. So the total distance from 9 to 16 is m plus n, that is 1 plus 6, which is 7. So we can therefore estimate the square root of 10 to be approximately equal to 1 times 4 plus 6 times 3 divided by 7, and that is equal to 22 over 7, which is equal to 3.143. Now, using the lower interpolation formula, we can also find the square root of 10 as follows. Square root of 10 is approximately equal to 3 plus m is 1, m plus n is 7, and that will give us 3 plus 0.143, which also gives us 3.143. Also, using the upper interpolation formula, square root of 10 is approximately equal to y is 4 minus n is 6 divided by n plus n 7. 4 minus 6 over 7 is 4 minus 0.857, which also gives us 3.143. Check. Multiplying 3.143 by itself gives 9.878. This is less than 10. This implies that the above formulas underestimate the square root of 10. Proposition. The formula given by square root of z is approximately equal to x plus 2m all over 2d minus 1, where m is equal to z minus x squared, and x squared is the next square number less than z. D equals to y squared minus x squared, and y squared is the next square number greater than z. That formula provides a better estimate than the preceding ones. Let us demonstrate this on a number line. This is the point representing the non-square number z, and we wish to find the square root of z. And let this be the point x squared, representing the next square number less than z, and the square root of x squared is x. This is the point y squared, representing the next square number greater than z, and the square root of y squared is y. Now the distance from x squared to z is m. That is z minus x squared. The distance from x squared to y squared is d. As this distance, y squared minus x squared is d. Let us now use our proposed formula to find square root of some non-square numbers. Here is our proposed formula. Square root of z is approximately equal to x plus 2m over 2d minus 1. Let us use it to find the square root of 2. Here the next square number less than 2 is 1, and the square root of 1 is 1. The next square number greater than 2 is 4. The square root of 4 is 2. The distance m from 1 to 2 is 1, while the distance d from 1 to 4 is 3. So putting d equals to 3, m equals to 1, and x equals to 1 into the formula, we obtain square root of 2 is approximately equal to 1 plus 2 times 1 all over 2 times 3 minus 1. That is 1 plus 0.4, which is equal to 1.4. Check. Multiplying 1.4 by itself gives 1.96. This is less than 2, meaning that our proposed formula underestimate the square root of 2. Let us also use the formula to find the square root of 5. Here the next square number less than 5 is 4. The square root of 4 is 2. The next square number greater than 5 is 9. Square root of 9 is 3. The distance from 4 to 5 is 1. That is, m is equal to 1. And the distance from 4 to 9 is 5. D equals to 5. Put m equals to 1, d equal to 5, x equal to 2 into our formula. That will give us square root of 5 is approximately equal to 2 plus 2 times 1 all over 2 times 5 minus 1. and that is equal to 2 plus 0.222, which is equal to 2.222. Check. Multiplying 2.222 by itself gives 4.9372, meaning that the formula also underestimates the square root of 5. Also, let us use the formula to find the square root of 10. The next square number less than 10 is 9. The square root of 9 is 3. The next square number greater than 10 is 16. Square root of 16 is 4. The distance from 9 to 10 is m equals to 1. The distance from 9 to 16 is d equal to 7. Putting d equals to 7, m equals to 1, and x equals to 3 into our formula, we have square root of 10 is approximately equal to 3 plus 2 times 1 all over 2 times 7 minus 1, which is equal to 3 plus 0.154, and this is equal to 3.154. Check. Multiplying 3.154 by itself gives 9.9477. This also implies that the formula underestimates the square root of 10. Also, let us use the formula to find the square root of 15. The next square number less than 15 is 9. The square root of 9 is 3. The next square number greater than 15 is 16. The square root of 16 is 4. The distance from 9 to 15 is m equal to 6. The distance from 9 to 16 is d equal to 7. Putting d equals to 7, m equal to 6, and x equal to 3 into our formula, we obtain the square root of 15 to be equal to 3 plus 2 times 6 all over 2 times 7 minus 1. This is equal to 3 plus 0.932 equals to 3.932. Check. Multiplying 3.932 by itself gives 15.461. This indicates that our formula overestimates the square root of 15. Algorithm for finding accurate square root of non-square numbers. Step 1. Find the lower bound L of square root of z and the upper bound u of square root of z. Step 2. Find the average a of L and u obtained in step 1. That is, a is approximately equal to L plus u all over 2. Step 3. If a squared is less than z, then set the lower bound L equal to a and repeat step 2. If a squared is greater than z, then set the upper bound u equals to a and repeat step 2. If a squared is approximately equal to z to a given number of accuracy, then stop and take the square root of z to be approximately equal to a. Example. Let us find the square root of 10 so that its square is approximately equal to 10 to 3 decimal places. Solution. Using the formula, square root of z is approximately equal to x plus m all over m plus n, we obtain the lower bound to be 3 plus 1 all over 7. which is equal to 3 plus 0.143, and that's equal to 3.143. Also, using the formula square root of z approximately equal to x plus z minus x squared all over 2x, we obtain the upper bound u to be equal to 3 plus 1 over 6, which is equal to 3 plus 0.167, and this is equal to 3.167. Now, let us average the two. The average of the lower bound L and the upper bound U is A equals to 3.143 plus 3.167 all over 2. And this is equal to 3.155. So, we check. Multiplying 3.155 by itself, that is A squared, is equal to 9.954. This is less than 10. This indicates that 3.155 should be our new lower bound. So we again compute A with 3.155 as the lower bound, then plus 3.167 over 2. Our new A is 3.161. Check. Multiplying 3.161 by itself gives 9.992. Again, this is less than 10, indicating that 3.161 is the new lower bound. We again compute A to be 3.161 plus 3.167 over 2, and this will give us 3.164. We check by multiplying 3.164 by itself to give us 10.011. This is greater than 10. This indicates that 3.164 is a new upper bound. So our A will now be 3.161 plus 3.164 over 2, which is equal to 3.163. Check. 3.163 multiplying by itself gives 10.005. Again, this is greater than 10, indicating that 3.163 is a new upper bound. So continuing that way, we can generate this table. We recall that our first lower bound was 3.155 and upper bound was 3.167, and the average is 3.161. Then A squared is 3.992, which is less than 10. So which shows that this is now the new lower bound. So in the next step, we now have 3.161 plus 3.167 divided by 2. That gives 3.164. The square of this is 10.011. This shows that this is now the new upper bound. In step 3, we have 3.161 plus 3.164 divided by 2. This is 3.163. Squaring this will give us 10.005, which is greater than 10, indicating that 3.163 is the new upper bound. Step 4, 3.161 plus 3.163 divided by 2 will give us 3.162. Squaring this, we have 9.998. This is less than 10. This indicates that 3.162 should be our new lower bound. In step 5, we have 3.162 plus 3.163 divided by 2. That gives 3.1625. The square of this is 10.001. This is slightly greater than 10, indicating that 3.1625 is the new upper bound. Then finally, in step 6, 3.162 plus 3.1625 divided by 2 will give 3.16225. When you square this, what you have will be 10.000 to 3 decimal places. So we stopped and then conclude that the square root of 10 is approximately equal to 3.16225.